Good morning, class. Here's Module 4, Chapters 8 and 9. Chapter 8, Hypothesis Testing. Chapter 9, Inferences from two samples. And here's Chapter 8, Hypothesis Testing. So answer the following. A test of hypothesis is always about a population parameter. The observed value of a test statistic is the value calculated for a sample statistic. As the sample size gets larger, both type 1 and type 2 errors decrease or increase. They decrease. Define type 1 error. Rejecting a null hypothesis when it's true, also known as false positive. Define type 2 error. Failing to reject a null hypothesis when it's false, false negative. So if the null hypothesis is true and we reject it, we are making a mistake. Type 1 error or false positive. And if the null hypothesis is false, we are supposed to reject it. And if we don't, we are making a mistake. That's false negative, type 2 error. The value of alpha is called the probability of type 1 error. The value of beta is called the probability of type 2 error. The value of 1 minus beta is called the power of the test, which is a correct decision, probability of rejecting a false hypothesis. So as you recall, 1 minus alpha is called the confidence level or confidence interval. So if we look at this table, preliminary conclusion, reject H0, fail to reject H0. H0 is some hypothesis. True state of the nature, null hypothesis is true. In this case, true state of nature, null hypothesis is false. So what happens when the null hypothesis is true and we reject H0, it's a false statement. It's known as type 1 error. And that means basically rejecting a true H0. H0 is a notation for null hypothesis. Probability of type 1 error is alpha. So if the null hypothesis is true and we fail to reject it, we are not supposed to reject it, we are making a correct decision, which is 1 minus alpha. 1 minus alpha times 100% also refers to confidence level and confidence interval. Now, if we know the null hypothesis is false and we reject it, we are correct. We are making a correct decision. And it's the power of the test and it's equal to 1 minus beta. However, if the null hypothesis is false and we fail to reject it, we are making a mistake known as type 2 error or false negative. Fail to reject a false H0, probability of type 2 error is equal to beta. So here's the synopsis of what we need to do as far as the test of hypothesis is concerned. In 1990, 5.88% of job applicants who were tested for drug failed the test at the 0.01 significance level. Test a claim that the failure rate is now lower if a simple random sample of 1520 current jobs, 1,520 current job applicants, results in 58 failures. Does the results suggest that fewer job applicants now use trucks? So this is known as the test of hypothesis. So first, let's discuss a few things, and that is, what is given? We are dealing with two outcomes. They either fail or don't fail the test, and that is a binomial distribution, where P is 5.8% or 0.058. Significance level, alpha 0.01. Sample N is 1,520. And out of those applicants, 58 failed. That means X is 50. So the very first thing is read and write the given. Now, you're dealing with a binomial distribution. So if P is 0.058, Q must be 1 minus that, 0.942. We should always check NP and NQ and make sure they are larger than 10, so we can use ND, normal distribution. Also, let's calculate P hat, which is X over N, 58 over 1520. So that's to get us started. So we want to do the test of hypothesis. The test of hypothesis involves the following steps. Step 1, H0, the null hypothesis, H1, sometimes they call it H8, the alternative hypothesis. And then you are going to write whether it's a one-tailed test, two-tailed test, and where the claim goes to H1 or H0. We will look at it as we look at this example and others. Step 2, calculate the test statistic. This has a formula, which you can find it in a formula sheet. For example, in this case, we are dealing with the proportion, so Z is P hat minus P over the square root of PQ over A. Now, traditional method, we find CV, critical value. That means we use alpha, critical value. Finally, after we go through the process, we make our decision. The decision is always and only about the null hypothesis. Based on the calculations, we make a decision about the null hypothesis only. Then we expand it. So what do? We either reject or we fail to reject H0. Then we look at the location of a claim, see whether the claim becomes true or false, depending whether it's sitting next to H0 or H1, and then restate this decision. And the way we restate it, there is or there is not sufficient evidence to support the claim that, and we do the writing. Let's go through the process. Now, in this question, I'm asking these parts, but even if I don't, anytime you have a test of hypothesis, do those 4 and then answer the questions. State the null and alternative hypothesis, calculate the value of test statistic, find the critical value, make a decision. Now, this is the end of this story. However, I want to discuss the p-value methodology, because instead of critical value, we may use the p-value method. Okay. And then statement of type 1 error. But the test of hypothesis has only 4 steps. There may be a different way of approaching it. So the formula that we need for this part from the formula sheet, z is p hat minus p over the square root of pq over n. So this is the same question. We want to stick with part A. Here's the given and the calculated part from before. And here's the z for part B. So let's stick with part A. Step 1, H0 P equals 0.058. When it comes to the null and alternative hypothesis, we only use a population parameter. We never ever use sample statistic. So that's H0. Now, what is H1? We will look at this. Does the result suggest that fewer job applicants now use drugs? So we're going to, the alternative would be fewer, less than. When we go with that, it becomes a left tail test. Less than is left tail test. More than is a right tail test. Not equal is a two tail test. And because we are looking at this concept, becomes a claim. So let's make sure everybody understands. H1P is less than 0.058 because of this statement. It is left tail test. Anytime you have a less than is a left tail test. Less than is a left tail test. As far as the claim is concerned, we are checking this, so we are going to keep that as a claim. Does the result suggest that fewer job applicants now use drugs? Becomes the claim. Number 2, or part B, we want to calculate the test statistic using this formula. And basically, we have this information plug in. P hat, and you want to use as many decimals as possible, minus P over the square root of PQ over N. It ends up being negative 3.309. The next step is to find the CV, the critical value. Critical value comes from the choice of alpha, which happened to be 0.01, and we are going to use the Z table. Here's the table. We use alpha is 0.01. It's one tail test, so there is one tail, not two. It's either on the left or on the right. Because it's less than, it's on the left, it's a left tail test. This area is alpha of 0.01. This area is alpha of 0.01. And this z-score comes from the table or technology. So this area, this area is alpha. And z is negative 2.33 or negative 2.325. So how do we make a decision? We just look at the location of a critical value and the test statistic. Where does this belong? Is it in the tail or non-rejection region? This is known as non-rejection region. And this is the rejection region. This is somewhere inside. So it's way inside. Clearly, this is inside the rejection region. This is less than the critical value. And therefore, the decision is to reject H0 because the value of test statistic is inside the rejection region. So the terminology is that this part is the rejection region and this part is non-rejection region, or. So So we made the decision. The decision based on it, the calculation is only about H0. Now we're going to expand. So what does it mean? If you are rejecting H0, loosely put, you're accepting H1. If you're accepting H1, you're accepting everything that goes with that. You're accepting the claim becomes true. And now you just reword it. There is sufficient evidence to support the claim that the failure rate among job applicants for drug is now lower. Results suggest that fewer job applicants now use drugs. So basically, you reword the claim and you put it here. And it goes either with there is or there is not. In this case, because the claim is true, there is. If it's not there, you can write exactly the same thing, but there is not sufficient evidence. If the claim becomes false, there is not sufficient. That's all. So all of these three steps result in rejecting or failing to reject H0. Now, this is the end of the story as far as the test of hypothesis. However, there are different methods. This is traditional method. And we use this method or traditional. We also use p-values. In many cases, including technology, they use p-values. So what is the p-value to begin with? So you start here with the type of test. The type of test, either left tail test or right tail test. That means you have your Z graph or T graph or chi-square, whatever the graph is. In the case of a left tail test, that means test statistic is a negative number, and the p-value is area to the left. The p-value area to the left of the test statistic. So in the case of a p-value, you compare it to alpha. In the case of a traditional method, you compare the critical value to the test statistic. If it's a right tail test, that means test statistic is positive, the area to the right of it. So p-value equals area to the right of the test statistic. If it's a two-tailed test, so is the test statistic to the right or left or center? This is left. P-value twice the area to the left of the test statistic. In other words, if your test statistic is negative, you calculate this area and you multiply it by 2. If it's positive, the same thing. You find this area and you multiply it to p-value is twice the area to the right of the test statistic in this case. In this case, twice the area to the left. If it's a two-tailed test, okay? If it's a two-tailed test. Here's the decision making. P-value is less than or equal to alpha, reject the null hypothesis. If the p-value is larger than alpha, fail to reject the null hypothesis. So for this question, and we're going to continue, we're going to look at the p-value and make a decision. Same question. This is for practice. We know it was a left tail test with the Z test statistic of negative 3.309. The p-value is area to the left of this test statistic. So here's the test statistic of negative 3.309. And therefore, we are looking at this area. And we are comparing this area to this alpha. That's the concept. Remember, the CV or critical value was negative 2.33. So p-value is the probability of z less than negative 3.309. That means this blue area from the table, from the technology, either way, and we come up with this number, 0.0005, which is way less than alpha of a 0.01. And we make the same decision, which is rejecting the null hypothesis. And therefore, when we make a decision, it has three parts. This is the first part. The other two parts just repeat. So we have a choice of using the critical value, negative 2.33, and test statistic, and just compare two numbers. This number is in the rejection region, reject H0. It's not, it failed to reject. Or we can compare the area. This gives you the p-value, and this gives you alpha, and you can compare the two areas. As far as technology is concerned, with the TI calculator, one proportion z-test, stat test, one proportion z-test, and enter the following. We want the value of p, which is 0.058. We want x, which is 58. We want n, which is 1520. And then we make a decision whether it's not equal, that means two-tail test, less than, that means left tail test, or greater than, that means right tail test. And then when we do the calculation, it gives us this. Look at this value. This was the test statistic that was calculated. This is the p-value. Now, the p-value from the table gives us 0.0005. I hope you realize this means 4.67 times 10 to the power of negative 4 times 10 to the power of negative 4. In fact, let me write that so you can see how that works. This one is 4.67, let's say 3 times 10 to the power of minus 4. And I hope you remember scientific notation. You look at this decimal and you go to the right. 4 places 1. Then you have to add 3 zeros, which makes it, let me just write that, which makes this one 0.3 zeros, and then 4, 6, 7, 3. And as you look at this number, if you stop here, you have to change it to 5, which becomes the same thing. So you make that decision. Now, what is type 1 error? What is the probability of making type 1 error? Reminding you, type 1 error, by definition, is rejecting H0 when H0 is true. And as you recall, in this case, H0, P was 0.058. And we rejected because it was false. But now, rejecting the claim that the failure rate of job applicants who were tested for a drug is 5.8% or 0.058, when the percentage is actually 5.8%. So if it's really 5.8%, and we reject. What is the probability of type 1 error? Alpha is equal to 0.01. By the way, I wanted to show you this one. I thought I didn't. So this p hat that is calculated here is here. A sample of 54 bears has a mean weight of 182.9 pounds. Let's assume that the standard deviation of weights of all such bears is known to be 121.8 pounds. At alpha of 0.1, is there enough evidence to support the claim that the population mean of all such bear weights is less than 200 pounds? Let's write the given. A sample of 54, n is 54. The mean weight is 182.9 for those 54. That means X bar is 182.9 pounds. Let's assume the standard deviation of all. So the population standard deviation, because it says all, and that's the assumption. Normally we don't know it, 121.8 pounds. Alpha, significance level of alpha, 0.1. Is there a claim? Is there enough evidence to support the claim that the population mean of all such bear weights is less than 200 pounds? That means mu is 200 pounds. So this is the given, everybody. So understanding the given first. Now, step 1, H0 and H1. H0 mu equals 200. Please understand what we put here is some sort of a population parameter. So what are we testing? That the population mean mu is less than 200. So equals 200. Now less than 200 for H1, mu is less than 200, which makes it a left tail test. And that is the claim. Is there sufficient evidence to support the claim? So this is the claim. It's a left tail test and mu is less than 200. The next one is to calculate the test statistic. The test statistic in this case is Z equals X bar minus mu over sigma over square root of n. Because sigma is known, we use this formula, and that's why the given comes handy. Plug in to calculate the test statistic. X bar 182.9 minus mu 200 over sigma 121.8 over the square root of n or 54. And it gives us the test statistic of negative 1.0317. Now, by the traditional method, we go with the critical value and the choice of alpha, which happened to be 0.1. So this area is 0.1. We read the Z from the table or technology, and we end up with negative 1.285. So alpha is 0.1. Here's a left tail test, and we read this number to be negative 1.285. The fourth step is to make a decision. And how do you make a decision? Look at the location, okay, critical value versus the test statistic. This is 0. So you put this here, definitely somewhere here, and that puts us way into the non-rejection region. Where is the rejection region? The tail or tails. In this case, we have only one tail. So way into the non-rejection region. Okay. Therefore, the decision is simple. Fail to reject the null hypothesis because the value of test statistic is inside the non-rejection region. The next couple of parts are the expansion on this concept. So the test of hypothesis only makes a decision about H0. Then we expand. If we are rejecting H0, we are accepting H1. If we fail to reject H0, that means we reject H1. If you're rejecting H1, you're rejecting the claim. The claim becomes false. And so there is not sufficient evidence to support the claim that the population mean of all bear rates is less than 200 pounds. So you rewrite this with either there is or there is not. In this case, whenever the claim is false, there is not sufficient evidence. And we're done. This is the traditional method when we use the critical value. It's a traditional method. Very simple, everybody. Let's look at the p-value. The TI calculator will give you the p-value, z-test, stat test. And what do we enter? Just take a look. We put the value of mu, which is 200. We put the value of sigma, which is 121.8, and then x bar, which is 182.9. That's why this given really comes handy. Make sure you write the given, make sure you write formulas. N is 54. And over here, you decide on less than, and we calculate. Click on calculate. Gives you this. Notice what it gives you. The z-score for the test statistic is calculated here with a lot more decimals, of course. But pretty much the same. They don't give you the critical value class. Instead, they give you the p-value. Take a look at this number, 0.1511, and it continues indefinitely. And definitely, this is larger than alpha of 0.1, failed to reject the null hypothesis. So p-value, which is 0.151, let's stop here, larger than alpha of 0.1, we have the same decision, failed to reject the null hypothesis. Failed to reject the null hypothesis. Number 4, 16 new textbooks in the college bookstore had prices with a mean of 70.41 and a standard deviation of 19.7. Use a 0.05 significance level to test the claim that the mean price of a textbook at this college is less than $75, assume normal population. Now, let's write the given. N is 16. Now, those 16 books have a mean of 70.41, that's X bar, and those 16 books have a standard deviation of 19.7, that's S. Alpha 0.05, and we are testing the claim that the mean price of a textbook is less than this. That means the mu is 75. So this is the given. Of course, we are assuming normal population. Obviously, sigma is missing. We have S. So instead of Z, we are going to calculate in real world. Most of the time, we deal with T, equals X bar minus mu over S over square root of N. So the very first step is to write H0 and H1, H0 mu 75. H1, whether we dealing with H1, the mean price of a textbook at the college is less than, so H1 mu is less than 75, which makes it the left-tail test again. And it is also the claim. So be careful where you put the claim again. And it's not always there. It just so happened that it's there for now. Now we calculate the test statistic using this formula. Test statistic is X bar minus mu over S over square root of N. Use this and plug in. We get 70.41 minus 75 over 19.70 over square root of 16. And it results in negative 0.9320. Now, with the traditional method, we have to find the critical value from the choice of alpha, which is 0.05. And since it's the t distribution, degrees of freedom n minus 1 which is 16 minus 1 equals 15. 16 minus 1 is 15. And we go with the table. And as you look at the table on the left column, you look for number 15. So we find that. And then area in one tail is 0.05. Area in one tail is 0.05. So the answer is 1.753, and we should recognize this as negative because this means for a confidence interval, negative and positive. Therefore, this is only negative because it's a left-hand test. To make a decision, we're going to put everything into a graph. Here's the t-distribution. Here's the critical value of negative 1.753 because alpha is 0.1. Test statistic of negative 0.932 puts us way into this area, which is a non-rejection region. And this is the tail or the rejection region. So, fail to reject the null hypothesis because the value of test statistic is inside the non-rejection region. So if you're not rejecting H0, what are you rejecting? You're rejecting H1, and therefore you're rejecting the claim. The claim is false. And now, there is not sufficient evidence to support the claim that the mean price of a textbook at this college is less than $75. And we're done. Let's look at technology. We use TI calculator, mean, t-test, stat, test, t-test, enter the following mu, x bar, sx, and choose. So we are going to put t-test, stats. We're going to put, because we could put data, by the way, if data is given instead of the stats, instead of x bar and s, if we have a bunch of data. In other words, all those 16 books, the prices, if we have to put the data. So 75, x bar 70.41, s 19.7 or s sub x, n is 16, and it's a left-hand test. You do the calculation. It gives you this result. Let's see what it gave us. First and foremost, take a look at test statistic that we calculated versus theirs. If you stop at 1, if you change it to 2, becomes basically the same. Doesn't give us, it does not give us the critical value. Instead, it gives us the p-value, which is 0.183, and that is larger than alpha, which is 0.05. And we make the same decision, which is fail to reject the null hypothesis. Tests in the author's past statistic classes have scores with standard deviation of 14.1. One of his current classes now has 27 test scores with a standard deviation of 9.3. Use a 0.01 significance level to test the claim that this current class has less variation than past classes. Does a lower standard deviation suggest that the current class is doing better? Assume the population is normal. We have to have a normal distribution or a large N to move on. So the reason I want you to understand and write the given symbolically, because in this example, you have standard deviation for both cases. So starting from the top, this is the standard deviation for all. That's the assumption. So sigma is 14.1, whereas n is 27. And for those 27 test scores, standard deviation or S is 9.3, alpha is 0.01. So we have a normal distribution. That's the assumption. Sigma is 14.1. N is 27 and S is 9.3. So you should be able to distinguish between S and sigma. Population standard deviation sigma is 14.1. Sample standard deviation S is 9.3. Alpha is 0.01. And we start with the first step. It says what are we checking? Use a 0.01 significance level to test the claim that this class has less variation. When it comes to variation, you can use sigma or even sigma squared. So let me make sure everybody understands what's going on. So H0, the first step, sigma equals 14.1. If you want to go with the variance, is fine. You can put sigma squared and you have to square this. Don't mix them up. Either one is acceptable. You just want to make sure you write the correct one that they ask you. So either sigma is 14.1 or sigma squared is 14.1 squared. Now, that's step one. It's always the equality that takes place for H0. H1, however, is either less than, greater than, or not equal. So the inequality goes for H1. And this one says, claim that this has less variation. Again, sigma is less than 14.1, which makes it left tail test. That happened to be the claim as well. Step 2 is the test statistic. Test statistic has a formula. Chi-squared is n-1 s squared over sigma squared. We wrote the given. We plug it in. 27 minus 1 times 9.3 squared over 14.1 squared. When you do the math, you end up with 11.311. That's the test statistic. CV, the critical value, comes from the choice of alpha and degrees of freedom. Alpha is 0.01. Degrees of freedom is n-1. N-1, 26. This is a left tail test. And we need the area to the right. So here's the chi-square table. Here's the left column. And the degrees of freedom we are looking for is 26. And the top row, we want area to the right. This is area to the left. Area to the right is a 0.99. Is in the wrong spot, everybody. And so it's 12.198. So if we look at the graph, the critical value is 12.198. And the test statistic is way into the tail, the rejection region. So clearly reject. The first step is to reject the null hypothesis. Because the value of test statistic is inside the rejection region. So very straightforward, everybody. So what happens next? Well, let's go back to the very first step. We are rejecting the null hypothesis. If we are rejecting the null hypothesis, that means, loosely put, we are accepting H1, we are accepting the claim is true. And now we rewrite as there is sufficient evidence to support the claim. So there is sufficient evidence to support the claim that this current class has less variation than the past classes. However, a lower standard deviation does not suggest that the current class is doing better. It just means that the grade is more homogeneous, closer to the mean. Mean value might be different. So what it means is that the smaller the standard deviation, the closer the group together, whatever that you are interested in. If the grades are close, that means the students are similar in their test taking. If I were to use the technology can't do the test for us. What it does, it can give us the p-value by finding the chi-squared CDF. And that means go with second variables, chi-squared CDF, and enter what you need to enter. So what do we need to enter? So chi-squared CDF. The lower is 0. Remember, it goes from 0 to infinity. The upper is 11.30.311 because the p-value is the area to the left of test statistic. So test statistic area to the left of 11.311. Degrees of freedom is n minus 1 or 26. And this is the number. So what is this? This is the p-value. From the technology, this p-value, let's say we stop here, becomes 5, and this becomes 6, right? Because it makes sense. So the p-value is, compared to alpha, is less than alpha. This is the p-value. 0.0056 less than alpha, which is equal to 0.01, and we have the same decision, reject the null hypothesis. Reject the null hypothesis. Now, by any chance, if you go to this website, if it works, sometimes it doesn't, you can do the chi-square test for variance calculator. So there are many calculators that I have put in the module 0 of my OpenMath. You can take a look at this one as well. Consider a population of frogs living on an island. We believe that the frogs may be members of a species called Rheinapipiens. The mean length of Rheinapipiens is known to be 11 centimeters. The following length values in centimeters were obtained for a sample of individuals from the island. Here's the numbers. Do these frogs have sizes that are consistent with them being Rheinapipiens or not? Are these frogs Rheinapipiens or not? Use a 0.05 significance level. In science, unless it's medicine, which is a different story, normally we go with the 0.05 significance level, even if they don't mention it. But I want to be clear on that. And so what's happening, let's write the given. The given is, first you count 1, 2, 3, and so forth. N is 20, alpha is 0.05. You need, and mu is 11. So this is what's given. N is 20, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 20, 12, and so forth, right? And alpha is 0.05, mu is 11. So that's the given. We need to calculate the X bar and S. We put this into some sort of a technology. For example, a calculator. It gives us X bar and S. You don't have to do this by hand. But as far as the formula, X bar is summation of X over N, and S is summation of X minus X bar quantity squared over N minus 1. So you put it into a calculator. If you need the information, you're ready to move on. Step 1, H0 mu equals 1. And let's say that's the claim, meaning mu equals to 1. The mean length is equal to 1. And therefore, this group is the same frogs known as Raynaud pipiens. That's the meaning of it. If you don't know what the claim is, you can always make it up. Pick up some part, H0 or H1 to be your claim. H1 mu is not equal to 11, and it makes it a two-tailed test. Please understand what's happening here. As long as the mean is different than 11, it can't be the same type of frogs. That's why it's not equal, and it's a two-tailed test. So we use the test statistic to calculate this. X bar minus mu over S over square root of N. We put the information in. 10.525 minus 11 over 0.9043 over the square root of 20 results in test statistic of negative 2.3491. Critical value comes from the choice of alpha, which is 0.05, degrees of freedom n minus 1, which is 90. And from the table or technology, we end up with t being plus minus 2.093 because it's a two-tailed test. Two-tailed test. So in order to make a decision, we are going to look at the graph. Here's the graph. So this is negative 2.093. This is positive 2.093. Test statistic, where does it go? It's less than this number. So take a look. This is negative 2.093. This is positive 2.093, and negative 2.3491 puts us way into the rejection region on the left side. So reject the null hypothesis. If you're rejecting the null hypothesis, let's go back to step 1. If you're rejecting the null hypothesis, you're rejecting the claim. The claim is false. Therefore, there is not sufficient evidence to support the claim that these frogs have sizes that are consistent with them being Raynaud pipiens. So what's the conclusion? These are not Raynaud pipiens. Here's the technology from Excel. Look at these two numbers. Test statistic, of course, with a lot more decimals. Critical values, plus minus 2.093. P-value, 0.02979. Compare it to alpha, which makes it less than alpha of 0.05. And therefore, you have the same decision, reject the null hypothesis. Reject the null hypothesis.